Okay, hello girls. The lesson is being recorded right now. Like last time, during the lecture, you don't have to turn on your camera, but sometimes I will ask you to. And also, just to make sure you're all attentive, I will ask questions quite often. So when your name is mentioned, you need to react quickly. Okay. Um, Now, regarding the homework, I think we seldom do 2 times homework for one section, but since we have quite a long break, so this time I asked you to do 2 assignments. Anyway, I hope that you could find which steps are expected. So maybe you can get an A. Now, remember, I think it's important to show the simplified function. It's important to show the simplified function. Some of you didn't show, you just skip this. I think you need to show this. And another important thing is the substitution. I also want to see it, and some of you skip it. You shouldn't. The simplified function and the substitution, I think those are marked. Okay. Now, in order to remind you what we have learned last time, is basically the meaning of limits, and we try to obtain the limits at a broken point. For example, if there is a function and there is a broken point here, you will find the limit by factorizing, basically. The technique is factorizing. And after factorizing and simplifying, you get continuous function, and it's easy to find. We also made a very quick start towards the end of the lesson. We mentioned another kind of limit. Now, this kind of limit on the graph looks very different from the first type because it's not a broken point. This type of limit happened at infinity or negative infinity. What do I mean? It means at infinity there's no infinity is not a number, so it's not broken there. And when it has a limit, it refers to a graph like this. If the limit is L, it refers to a graph. We don't know what happened here, but at infinity, this curve will get closer and closer to this horizontal line where the value is L. Now, of course, not every function has this feature. For example, parabola doesn't have this feature, as parabola will just go to infinity itself. I mean, the value of y will increase indefinitely. But some function has this feature, and we have met one of them, two of them, one of them. That is the exponential function. The exponential function, when we learned it, we know, oh, it's going down. And we know at infinity, this value will get closer to 0. And in this case, this function has a limit at infinity. And we also had a name for this type of feature, where I call the curve is asymptotic to the straight line. Okay, the curve is asymptotic to the straight line, or you can say the straight line is an asymptote to this curve. Okay, now in this section, now if we're going to find a limit for this type of for functions at infinity, we're basically getting a horizontal asymptote for these functions. And the technique, you can see what the technique is. The technique, I believe, is no longer factorizing anymore. It's not. Anyway. Now, last time I think I mentioned, make sure you change this. There is a typo here. Now, if one function tends to infinity, then the reciprocal should tend to 0. Now, we're going to use this repeatedly, so you know later on I will mention it again. Now, theorem 4.5, this one is similar to the previous 4.3, where we had limit at a broken point. These still works, and the principle are very similar. You can add, you can subtract, you can multiply, you can divide, you can take out a factor. Now all that, and make sure you know that if at any point you cannot work out this way, it may not be the limit does not exist. Maybe your method is incorrect. Okay, so this method is like this. If it does work, then fine. If it doesn't work, it doesn't mean the question is wrong. It means you need to find another method. It's not like any method we learned before. If the method doesn't work, that means the question has no solution. It doesn't work that way. I will show you. I will show you. Example 6. So this limit, now how do you find it? You can use the third property, what do you call it? Theorem 4.53, the third one, where this is equal limit x tends to infinity 6 minus limit x tends to infinity 2 over x plus limit x tends to infinity 1 over x squared. Okay, now for the first one, it's a constant, so the limit is itself. For the second one, this is a function that you can use this property where, oh, maybe it's not 1, it's 2. Here it's 2. So maybe I'll take out 2 and make it 1 and take out 2 here. Okay, in this case, the denominator tends to infinity. Therefore, the reciprocal tends to 0. That's why you can write 2 times 0. And the last one is also 0 by the same principle. So the answer is 6. Another example would be this one. negative infinity. Okay, negative infinity. And this will be 1 minus log negative infinity 3 to the power 5x minus 1. Sorry, some people are waiting to get in the... Some students are waiting to get into the Zoom lesson. Let me allow them. Now this one is 5x, sorry. 5x minus 1. And for the first one, it's 0. For this one, it's negative. Let's say it's, you can take out 1/3. Remember, you can take out 1/3. And then you can do 3 to the power x, and then to the power 5. And to the power 5, you can make it here. Okay. Now, I used a lot of theorem. I used the sixth one. Now it's the to the power, the limit, the power limit is the limit power. You know what I mean? And also I took out a constant. I also did the constant. The first one, limit one is 1. Sorry, limit 1 is 1. Why did I say 0? Limit 1 is 1, and all that. I just used all the. I took out factor. I did the theorem 4.6 and all that. So that I think each part is easy for me now. Now this one is not a property. This limit is something that we know already, because we know at negative infinity, the exponential function at negative infinity, this side is 0. This part is like should be in your backup knowledge. Okay, so this part is 0, and then to the power 5, so you get 1. Basically, that's how it works. Now, I know it's not very clear. It's not very clear. But will you try? Try these two. Try these two. And turn on your cameras. When you're done, you let me know. You let me know. You can put up your hands when you're done. Okay, most are done. Now this answer, I just copied I just copied the example. That's not the correct answer. For this one, you say, oh, it's limit to, you separate them, right? And also you take out 5. And then you get 5 times 0 minus 2, you get minus 2, okay? For the second one, you take out 5, you take this. Am I not? I think, yeah. You take this is negative infinity, okay? But this time it's 6 to the power x and then squared, okay? And then you get 5 times 0 squared, you get 0. Is that okay? Now, of course, a lot of students can see the answer like, oh, do I really have to write this? Just maybe just for the first week, okay? Do you really have to write this just for the first week? Just for the exercise this week, and you will see, I think you should actively think that you are using some of the properties, some of the theorems that's in 4.5. Otherwise, I think you gain the most if you use it, in my opinion. 7. You see, today we don't do factorizing, do we? Right? Now, example 7, also you see the type is at infinity, so factorizing, I don't think it will help. So the most common technique is to make more fractions. Now, what do I mean by make more fractions? I mean, this is 1 fraction, right? But that's not enough. I'm gonna create fractions everywhere. Now, how do I do that? Positive infinity. Now, if you don't write positive, that means positive, okay? This one I will divide x squared, so I get 2. This one I'll divide 9. I'll divide x squared again. For each term, I will divide x squared. Okay, and then I will apply the theorem 4.5 to really to every bit of this function. I take out 9 as well. This is, take out 4. Oh, I wrote log, LIM. 1 over x squared. Okay, so these are what we're most comfortable, these ones. 1 over x, 1 over x squared, we're most comfortable. So then we can put in the values. And then equal to. The second question. It's negative infinity. This one also I will create more. Now this time I will divide something, but I want, now you must be, you must wonder this time what I'm going to divide. Now I can divide x, I can also divide x cubed, and I'm choosing to divide x cubed. Okay. So I get 4 over x squared plus 5 over x cubed, 6 minus 2 over x plus 1 over x cubed. And then the same thing. I know you may think, oh, do I have to write all that? Just for today. Okay. Now, again, I hope you're comfortable with this. Now, although this is negative infinity, 1 over x still tends to 0. So it's negative, but also tends to 0. Because if you recall this graph, this is our first graph, right? This 1 over x on the left still tends to 0. So it doesn't matter whether, in this question, it doesn't matter. It's negative infinity, positive infinity, you get 0 as well. So here 0, here 0, here 0, here 0. And then you will get 4 times 0 plus 5 times 0. And then plus 6 minus 2 times 0 plus 0. And then you get 0 over 6. And that's okay. Now, girls, it's fine to have 0 over 6. There's no problem with 0 over 6. The other way around is not allowed. 6 over 0 is not allowed, but 0 over 6 is still fine. You're still safe, okay? So the first one, I divide x squared. I think you know why I divide x squared. The second time I divided x cubed. you will know, you will know. The last one. The last one, I will divide x squared. Okay. Okay. And this one, and this one, I'm going to use it on everything. Okay. Now, when I use it on everything, I'm safe with the last one. I'm safe with this one, but I'm not safe with this one. Okay. Now, this one, there is no value. Now, because there is no value, what did I say? I said, oh, because there is no value, that means you cannot say, oh, you cannot just say, oh, this question is wrong or whatever. When you have something like that, you should scratch it. That what I mean is this method does not work. So what you should do, if you read your textbook, you will see that when you do this and this doesn't work, what you should do is to erase it. And I'm just gonna cross it out. And I'm going to have another attempt. My attempt is this. Please wait for me. I want to be 100% sure, so I will turn on the textbook. I mean, how you should present your answers. One moment. Now, when something happens like this, it means you need to present it the best way. Chapter 4. When something like this happens, you can turn to page 7. Is it page 7? Page 18, sorry, page 18, example 7. This one, part C. If this happens, what do you write? Okay. What is it? This one, page 18, example 7, this one. If this happens, then what do you write? You don't keep this. You don't keep this. You do not work on. You do not carry out. Okay. What you write is when x tends to infinity, this tends to 0, and this tends to 0, and this tends to 0. So the whole thing tends to infinity. Therefore, the limit does not exist. Now, to translate that here to our question, how should I present? Maybe I shouldn't, sorry, I shouldn't scratch everything. I should scratch this, just this part, because this doesn't work, but the previous step still works. I can say when x tends to positive infinity, the numerator tends to infinity, but 2 plus 5 over x tends to 2. That's the numerator infinity. The denominator tends to 2. Therefore, the whole thing tends to infinity. Therefore, this limit does not exist. Does not exist. Not just that, oh, you write does not exist. You must write why you think it doesn't exist. Our basic principle is that, oh, the denominator is 2, but the numerator is getting to infinity. Of course, that's not going to approach to any constant value. It's going to increase or decrease. It's going to increase indefinitely. So for the first 2 questions, there is limit. For the last question, there's no limit, and then you need to know why. I think the most important thing is that you know why there is no limit. Now you have a go. You have a go. And when you're done, you put up your hands and let me know. Turn on your camera. Turn on your camera. Okay. This time I waited longer. Now you take what you've done and really compare yours with mine. Okay. Now the first question, I think it's easy because you know what to divide, right? And then you can use this theorem. And then you get every bits. This one, especially these two. And then you get the answer. But the second question, is it -5? Oh, yes, it's -5. -5. Sorry, I made a mistake. It's -5. -5. So -5/6. Thank you. For the second question, now this one, I choose to divide x squared. Now my habit is that I think you guessed it now, right? My habit is that I will divide the largest power it has in the denominator. Now I will divide square. If this is square, I divide square. And then I'll divide the largest in the denominator. It always works out for me. Now, when I do that, I will find, oh, I cannot use the property anymore because my numerator will tends to infinity and my denominator tends to 4. So the whole thing, the whole function tends to infinity. Therefore, the limit does not exist. Is that okay? You learn how to write it and you feel, oh, this is correct. Unless you have another way. In that case, you let me know. Or you show that in your exercise. So I will mark it. The last question, it's given to you factorized. However, you do not have to expand because expanding takes time. For you, maybe it takes like seconds, but still. Now, since the power in the denominator, the highest is 2, so I will divide x squared. You see, I divide x squared. I also divide x squared here. Now, for the denominator, I divide x in one bracket. I also, sorry, I divide x in one bracket. I also divide another x in another bracket. Is that fine? So altogether, I divided x squared. I divide one x in one bracket, divide another one in the next bracket. Therefore, I don't have to, I spread them out. Therefore, I don't have to expand. I don't have to break the brackets. And then after doing this, I will use the property on every little part in this fraction. Every part. The first 1, 2, 3, 4, 5, 6 parts. Each part I take limit. Every part I take limit. And luckily it works out for me because everything will make sense. I mean, there is no undefined. There is no infinity. Unlike part B, there is something that's infinity, which is not okay. And in this case, everything works out fine. Although the numerator is 0, again, this is fine. A numerator can be 0, and the final answer is 0. Is that okay? I think that covers every different cases. When you have a polynomial divided by another polynomial, it's either A or B or C. Okay. So that's it. That's it. Let's move on to more complicated examples. In example 8, you also have limit at infinity. But this time you have square roots and you don't have fractions anymore. Basically, because it's not even rational this time. Now this will, I think this will increase the difficulty as our technique focuses on the use of fractions. So you can see in the solution that we still make use of the fractions. But first, I need to create fractions myself. For this one, I will write limit. And there is no fraction. I will create by, you may not believe me, but I'm going to multiply the conjugate. And divide the conjugate. Okay. Now, this does two things. One, I can rationalize. Something will get rationalized, right? Something. And also, I will create a fraction, which will be useful. You will see. I will simplify a little bit. For this one, it's x minus 1, okay? Okay. Now, when I have a fraction, I will make every little bit's fraction. I will make every little bit's fraction. Now, this time is more complicated because it has thirds. However, I will still divide the highest power in the denominator. In this case, the highest power in the denominator is 1. 1, x to the power of 1. So I will divide. But this time when you divide x, I know it's divide x, but in the bracket, you are dividing x squared. Not this time. Not in the bracket, under the radical sign, you are dividing x squared. Okay? So that is one step, okay? And then you will use the limit in every little parts. Now this time I'll write less. I'll just write 1. I'll write the other one limit. For this one, I will also write inside. This one, I'll write 1 plus this. 1 plus this. You know what I mean? You see, I have fractions everywhere now. Here, 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 here. I have 6 places, okay? Right now, I will just depend on my backup knowledge. I know these are 0, and then I will put them in. Okay, and then I will get 1 divided by 1 plus 1. And the answer is 1/2. Is that okay? So if you don't believe, oh, this is 1/2, I also talked about a trick that you can use with your calculator, right? But in this case, what can you substitute? You can substitute x equal 10 to the power 5 and put it in. and see if the answer is really very close to 1/2. You just input square root 10 to the power 5 squared plus 1, plus 10 to the power 5, close bracket, minus square root 10 to the power 5 squared plus 1, close bracket. And then use the calculator. My calculator show 0.499993751. So that checks out. I think it does get closer and closer to 1/2. If I put an even larger number, it's gonna get even closer. You know what I mean? Okay. Now for example 8, the technique is to rationalize and also create a fraction. And after the fraction is being created, is there. I mean, after this step, you can create more fractions by dividing. But this time, because you're working with the thirds, that may be difficult. Now you can try. You can try. The answer is almost like unexpected. You don't know the answer is 1/2, don't you? You don't know. This one you really cannot guess. It's not so obvious though. Now you turn on your camera and do the classwork. When you're done, you let me know. Some students haven't done the classwork for the last 2 times. Then later I will check on you. Okay. Now, this time, because the answer is not given, I will ask a student to answer. How about Cindy?
1.
1, correct. The answer is 1. Extra example. Now, extra example, it's the similar idea. It's just more thirds. Okay, more thirds. Now, if you have this question, what will you do? You will multiply the conjugate. The conjugate, which is just the conjugate of this. How about this one? You may ask, should I multiply root x as well? Now you think, should I multiply the conjugate of this? It will turn out that it won't be wrong. It just will not be necessary. Okay. And then you will keep this is 1, right? This one is 1. So you have root x divided by this. Okay. Now you later on you may wonder, like, Miss Chen, I think this is another irrational, right? Why how do I know which one I multiply and which one I don't multiply? You think there is a clue. There is a clue. I think that you should figure it out before I tell you. But anyway, now after I rationalize and simplify, you will see a fraction. And in the fraction, it's something infinity divided by another infinity. Okay. And then this time I will divide the highest power in the denominator. In this case, is root x. And this time I don't have x anymore. You know, it's root. This first term is root. The second term is also root. So my highest term is root. So after dividing, I get 1. And this one, I get x plus 1 divided by x. And this one, I get 1. Okay. And then I can make it. Now this now with the constant, I don't want to write the limit anymore. I will just write 1. For this one, I will write the limit. Okay. And then I will put in. I get 1/2. Is that okay? Basically in today's lesson, you should feel very differently from the previous lesson. And we don't do factorizing at all. Right? We don't do it at all. Now, in the previous lesson, you also have a fraction, but you always want to delete. You always want to factorize and delete something. But in this one, you don't. You don't even look for it. Even if you can find something to delete, it does not matter that much. Maybe you can make it simpler if you can divide. You can delete a factor, but it won't help. It won't help you solve it. To solve it, you have to create fraction and then create more fraction and then use something. So that's the main idea. You will do exercise, but not now. Is it fine? About the last question I raised, which one I multiply and which one I will rationalize, which one I won't rationalize. when you do your work, you will feel it more. You will feel it more. And it's better that you can express it. If you know, if you can feel it, but you don't know how to tell another person, that's not called knowing. From my standard, if you know for yourself, you can feel, oh, this time I multiply this and that time I multiply that. That's perfectly fine for yourself. But my more higher level, if you can, if I could encourage you to think about, like, to explicitly describe which you multiply and which you don't. Like in this question, I don't rationalize root x, I rationalize the first one. Try to think about it. Okay, you should actively think about these problems. You try to solve these, like you try to resolve these dots, maybe some questions, and then you feel, maybe you feel better. You know what to do later in the exam setting. So far, any questions? Now, it really is the two types of limit. It really is. And I think that's the main idea of this chapter. You have type 1 and then you have type 2. Now, type 1 is the broken point. Type 2 is at infinity. Now, our next lesson is going to be type 1 again. Next lesson, we would look at some functions and try to find the broken point and try to factorize it and then make it whole again. But a little bit difficult though, because the factorizing part won't be so easy anymore. Now I'm going to close this now. Let me know if you have any questions. I'll give you 3 minutes, okay? You tidy up and then prepare for the next notes. Okay. Now we're back for the next session. And like I said, this session, the limit is not new. It's type 1. It's type 1. But the function is new. In this session, we will do type 1 limit, but with trigonometric functions. So that's the only different part. As you know, trigonometric functions are not easy to factorize. Right? Now, do you have to apply a lot of formulas? Some. Double angle formula, sum to product. These are factorization skills. You will be reminded when you need to use it. Now, first, this class activity, however boring you think it is, I think it's important to go through it at least once in your life. Now, here we want to find out the limit of sine theta divided by theta. Now, this function is not entirely trigonometric, nor entirely rational, right? It has a fraction, but also the numerator is trigonometry. So it's like a mix of the two. Now, the only way we can find the limit of this function, we have no better way other than experimenting. So here you're going to just try out a few values, and also remember the best you can rely on is your guess. You experiment and then you guess the limit. Now here x must be the value that is in radian measure. Now we do not use degree. Using degree will not work. Must be radian. So these angles are negative 0.5 radian, negative 0.1 radian, and negative 0.01 radian. Okay. Now you can see x cannot be 0. Now here 0 is omitted because this function is undefined at 0. So there is a broken point there. Okay, the whole graph, there's something here and something here, but there is a broken point in the middle. Okay, there's a circle, the broken point. And then you find out the values that is around this point, and then you figure out, you guess what the limit is. Now I'm going to do it very quickly because I know the answer from the textbook. You can use the calculator, but you have to change the degree measure to radian measure by press. I think it's mode setup, shift setup. Yes, shift setup, and then 2. Okay, so it's R. And then you press sine negative 0.5. It's negative 4 decimal places, 0.4794 sine negative 0.1, 0.0998 sine negative 0.01. It's negative 9.9. It's 0.001, I think. It's 0.001. It's 0.01, I think. It's negative 0.0100, I think. And then sine negative 0.001. It's negative 0.0010, like that. And these are similar, okay? These are just positive. This is negative. This one is negative, and this one is positive. 0.0998. This one is 0.4794. Okay, this is my value. And then I can find the ratio by experimenting. 0.5 divided by sine 0.5. That's 1.6687, 1.6687, and then 0. Oh, it's the opposite. Sorry, it's a reciprocal. It's sine divided by x. So sine 0.5 divided by 0.4. Sorry, 0.9589 and sine 0.1 divided by 0.1, 0.9983, sine 0.01 divided by 0.01. That's already 1.0000, 1.0000, and this one as well. Okay, now with these values, I think it's easy to guess, and this is the answer. Now in our curriculum, we're not proving it. We're not saying, oh, this is exactly 1, but you can guess it's 1, right? Now there is a proof that's written in the textbook. I think it's easy. I think it's easy to understand, but it's beyond our curriculum. Still, I will show it to you. I'll show it to you. This is regarded as a real proof of this limit. It's done in this way. It's done in this way. You just need to understand. You don't have to perform yourself, okay? Now, I will use area to create the function. Okay, now I will use area to create function. Now here, angle x, okay? Angle x, angle is x. And the circle here at A, the circle at A is of radius 1. So this is 1 and this is 1 as well. Okay. So our thing is, you will find the area of the sector ABC, and the area of the triangle ACE, and the area of ABD. And you will know that the area of the sector, the blue part, is larger than ACE and smaller than ABD. Why is that useful? Let me show you why. Now, ACE is basically I think it's base times height. Sorry, ACB, not ACE, ACB. ACB and ABD, sorry, but still, ACB. ACB is base times height, which is 1/2 times 1 times sine x. Okay, now ABD is 1/2 times base times height, which is this. Okay, and the sector area is, now let me work it here. It's pi r squared times x divided by 2 pi. Now x is the angle, 2 pi is the whole circle. I'm not using 360 degrees. I'm using x divided by 2 pi. 2 pi is the whole circle. So you can see the area of the sector is x over 2. Okay, so we create this inequality ourselves, which is sine x is smaller than x, smaller than tangent x. Now you create and simplify. Okay, and then you will divide sine x. The reason we can divide sine x is because we know sine x is positive. In this case, sine x is positive. Okay. Now, when we divide, you will know, oh, this, we will make x small. What do I mean? I will send x to 0. Now, this action is called send x to 0. This inequality, the left, the smallest value will tend to be 0. Will tend to be 1 because 1 is a constant. This side will tend to 1. The reason is cosine x tends to 0. X tends to 0. Cosine x tends to cosine 0, which is 1. So that is a value we know. So the value in the middle must also tend to 1. You know what I mean? This is like a squeeze. It's like a squeeze. What do I mean is that, oh, my function is between these two. Is between these two. And there are 2 other functions that is, one is above me and one is below me. But the one above me tends to 1, and the one below me also tends to 1. So if I am squeezed in the middle, then this function must tends to 1. You know what I mean? Anyway, that is I think that's considered as a proof. That's how you find out, oh, this function is weird function. It's a mix of rational and trigonometry. This limit is equal to 0. Now, why do we need to find this limit? Is because any other function we're going to work on today will have something to do with this function in the end. After simplifying, after factorizing, it will have something to do with this function. I'll show you how. I'll show you how. Now, this one is also true. Now, since sine x over x tends to 1, now x over sine x also tends to 1. You can use that directly. Example 9. This one, how do I work it out? This is sine 3x, and then this is x, but I'll change it to 3x, and then I'll change it to multiply 3. Basically, I'm dividing 3 and then multiply 3. Okay, why do I do that? Because I want to change it to 2 limits separately. Basically, I'll take out 3. Okay, but this time, instead of saying, oh, x tends to 0, I write 3x tends to 0. Okay, you know what I mean? Now I have a new variable. This is a new variable. Then I can use sine theta over theta tends to 1. So 3 times 1 equals 3, like that. Another one. So this one, it's sine x divided by cosine x times 1 over x. And it is equal to sine this over x times 1 over cosine x. I'll put them together. Whenever I see sine and x, I put them together. And then I will separate sine over x and cosine x. Okay. Now, the first, like I said, we already worked it out. So the first one is 1. The second one is continuous at 0. So this one is continuous. So it's okay. You just do substitution. And then you will get 1. I know it may look very scary with the cosine, but cosine is continuous. And 1 over cosine is also continuous at 0. So you can just put it. Last one. You see, I have a trigonometry divided by trigonometry. I will do sine divided by 5. And then basically what I did is I divided by 5 and multiply 2. And then I will do that back. You know what I mean? That this is not called simplifying, right? This is to make something up in order to create what I want to create. Okay, and then it's equal to 5 over 2, the first limit, sine 5x, okay, sine 5x over 5x, another limit, 2x over sine 2x. Now here I'll write 5x tends to 0, and here I'll write 2x tends to 0. And then I can create 2 special limits. Both are equal to 1. 5 over 0. Oh, 5 over 2. Is that okay? Now, if you want to write anything different from I just showed you, you can try in your exercise, and I will mark it, and I'll let you know whether or not yours is okay. Now you can try the classwork now. You try the classwork. Turn on your camera and let me know by putting up your hands when you're done. Okay. Now this is the first exercise. Please check what I've done here. Now, of course, I need to create something, right? I also show the step when I take out 1/3. I also change it here. My answer is 1/3. Second one, I also have two limits after I change cotangent. Eh? Sorry, I made it wrong. Oh. It's cotangent 2x. Sorry, I made a mistake. As 2x. Wow, what a mess. It's 2x. I didn't see 2x. Anyway, this is 2x, but here 1/2. So it's 1/2 times 1. This is 2x times cosine 0 equal 1/2. Our second one equal 1/2. Okay. And the last one, this is what I did. I need to divide 3 and multiply 7. And also after I've done that, I will multiply 3 and divide 7 to make it back. And then I'll take out 3/7. And then I will have two other limits. And these are special limits. So I use the result. So that's how it's done. That's how it's done. Now in the following examples, I'll show you how to use more technique. That is, something is involved. The trigonometry identities are involved. Okay. Now, your goal, I think in these questions, your goal is to create factorized form. For example, you have a difference here, you will make it a product. Okay, it has to be multiplication. You know why this has to be multiplication is because this whole thing, this type is type 1. And that means you have to make it product, no matter what kind of product. In this case, it's a product of trigonometric ratio. In the previous case, it's a product of polynomials. So when you see difference, when you see sum, you just make it product. Now, also when you make it product, you also have to really choose which one you use, and I'll show you how to choose which one I use, like that. Now the first one, very typical, very typical. Now when you see cosine, you must use this one. You know there are 3 of this, like cosine double angle. There are 3 of this. You must use this one because this one will give you sine square. You don't want cosine square minus sine square. You want this. You almost always want this one. Okay. So you will keep. This one will be 1 minus 2 sine x over 2 squared. It's half angled, you see? Now x become half angle, 1/x. I know it's painful, but you still have to do that. And 1 and 1 are cancelled, you see? You have -2, and that's fine. -2 is fine. Okay. Now, as you can see, -2 can be taken out. And then you will have sine x over 2 over x, which is sine x over 2 over x squared. Okay, not there yet. Not there yet. Because you need to change this to sine x over 2 divided by x over 2. Okay, and then you will make the square after the limit. You know what I mean? And because you divide 1/2, you need to multiply. This is divide, multiply. Divide 1/2 in the denominator. So you need to multiply 2 in the denominator. You know what I mean? So in reality, you're not just doing that. Maybe I write this. You're just multiplying 1/2 back and then squared. Okay. So in the end, you're doing -2 and 1/2 squared and then a limit squared. Now here is x/2 tends to 0 and this squared. So in the end, it's -2 times 1/4 times 1. The answer is -1/2. It's not easy when you first do that, but try to catch up. You follow me. You follow me. I know that maybe you want to simplify the steps, but you follow me first. Because this is what it is. You may want to write it a different way, but you're doing the same thing. You're doing the same thing. Next one is sum to product. You don't have a choice. You have to be sum to product. You have to use sum to product. This one is negative sign. -2 sine a plus b divided by 2, a minus b divided by 2. Okay. And then you will do -2 is fine. And then you will do sine 2x divided by x and sine x divided by x. You just separate them. Okay. And then you will do, here you will make 2x. So here you will multiply 2 and then you will multiply 2 back. Now here, this one should be matched. You multiply this 2. And then you multiply this one back. Let me address a question in the chat. Whether the coefficient of x should be. I will answer you later, Gladys. Okay, I'll answer you later. Now let's carry on with this. And now you will, I think it's time to take out -4, and then you will have the first limit, sine 2x over 2x, and the second limit, sine x over x. Okay, this one is 2x tends to 0, this one is x tends to 0. Then you get -4 times 1 times 1, you will get -4. Is that okay? It's not, as you can see, it's not really factorizing. It's not really factorizing. A should be positive. Sorry, I have another question in the chat. Girls, why do you think A should be positive? Because Gladys told me it was positive. And Wendy said it too. Well, what do you mean by positive? Oh, yes. I made a mistake again. Let me change it. Let me change this to positive. It's positive, okay? So it's positive, 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 and positive. Sorry, yes, it's positive. Why do I think it's negative? It's positive. Okay. Um, I think it's not easy even for me. It's not easy to know. It's not easy to figure out, are you dividing or multiplying? You just have to check yourself. Okay, like this one, when I divide 2 here, do you know that I'm actually multiplying 2? And then that's why I make it back by multiplying 1/2 here, right? And in this case, I'm multiplying 2 here, and then to make it back, I will multiply 2. Now here it's 1/2, and here is 2. You know why, right? So when we say dividing, when we say multiplying, I'm actually, in part A, I am multiplying 1/2 in the denominator. So I am multiplying 1/2 now to make it back. And this one, I am multiplying 2 in the denominator. So I'm multiplying 2 back. You know what I mean? It's not easy. You can, but you must gain experience yourself. It really nothing. Whatever I say will not help. You will know what to multiply and what to divide. Why don't I have exercise? Oh, I do have classwork. Can you do this classwork? That's it. That's it. Now these two, I will just do it later when you're done with the classwork. Okay. Now, if you're done, you check your answer with mine and find out if there is any difference, because I'm not next to you now. If I were next to you, I would point it out. But you just find out what's different, and then you may decide yourself. You decide yourself whether or not that's okay. Now, of course, I'm going to check it in your homework when you present your answer. Okay. Now, because the classwork is very similar to the example, so I think you may know, you have to use this double angle formula. You have to. Okay. And then you will have a square, right? You will have a square. Now, in order to use the special limit, I call the special limit x over sine x, the special limit. In order to use the special limit, I need to divide 2, multiply 2. Okay. And then I will take the 4 out, which is 2 square. And you can also see something happen because originally it was limit of a square. Now it's the square of the limit. Do you see that? This is a limit of a square. Now it's square of a limit. Okay, and then I use the special limit. In the final step, I use the special limit. Now, some of you will use it in the middle, which is not allowed. But I will mark it. In your homework, I will mark it. In the middle is usually is not allowed. It's not allowed. Part B. Now you can see sum to product. You have to. And then you have sine, cosine, cosine, sine. And then you would take out the sine and match it with x. Okay. You take out another sine and also match it with x. Now, because here you divide and multiply, so later on to make it up, you will multiply and divide. Do you see? You divide 9, you multiply 9. Do you see that? Now this part, however long it takes, you figure out a way to do that. As simple as possible for you, so you know what number needs to go there. That's very important because this is going to affect the answer. And then, because originally we have cosine and cosine, and remember you don't have to do anything with cosine because cosine is a very cool function at 0. So here, these two functions are actually continuous. So you can see later on, I just wrote the limit in. I wrote limit in. Because the limit of the function is the limit of the quotient is the quotient of limit, right? So I can do that, and that will be fine. But the first two are special limits. Special limits. And then I will have 1 times 1 times 9 times cosine 0 divided by cosine 0. And the answer is 9. Okay. That's all. But I will show you more because the exercise in your textbook, the exercise is not just going to be these 2 types. There are more types. Extra example. For this one, what you will do is, oh, you may think, what do I have to do anything? Do I have to expand? Yes, you can, but you also follow me, okay? Follow me. Now, because I know this function is fine, so I will not care. I will just change this to 1 minus 2 sine x squared divided by x squared. Now, what do I mean by this function is fine? This function is continuous at 0. So I'll just leave it alone. Now, I know that the only part I need to deal with is this divided by x squared. Okay, so you can see what I do. Now I will take out 2. And then I'll have sine x over x square. And then this one, I will just put it aside. Now you may think you have to deal with it, but you really don't. You really don't. Just leave it there. And then you will have 2 sine x over x, the special limit, and then square. You see, the limit of square is the square of limit, and then this. Okay, and then I'll put it in. Okay, and then it's 4. It's 2 times 2. Is it fine? So I guess if you expand, is it possible to still solve it? I think so. I think it's still possible, but you just have to realize at some point, maybe not now, but you be aware that in your function, there might be a part that is completely continuous and you don't have to touch them. And if you notice that, you will make your the whole process much simpler. Okay. Now for this part, this one is another type. Part B is another type. This one, I know for this one, it's the sine 3x and x you can factorize, right? You can do sum to product. But for 5x and 4x, this one, the denominator, it's impossible. That with 5x and sine 4x, there's no way you can really factorize it anyway. You cannot do double angle because one is polynomial and the other one is a trigonometry, you know. Now, in this case, in this question, we do not factorize this time. Now, of course, you can factorize this, but this would, after factorizing, because the denominator cannot be factorized, you only factorizing the numerator will not help greatly. That's just, I know that. And you will see another technique is used, okay? So if this happens, I will do dividing in every term. This one is very similar to the limits at infinity, but it's not. It really is not. This technique is like that, but it's not. It's not the same type. Sorry. Okay. And then, now when doing this, you're creating a lot of special limits in doing this. And then to do that, I will multiply 3 here and then multiply 3. And this one, I don't have to do anything. And with the last one, I will multiply 4 here and then multiply 4. You know what I mean? And then I'll write a lot of limits. It's 3 times the limit of sine 3x minus limits x0 sine x over x. This is 3x plus 0. This one is 5, and this one is 4 times sine 4x over 4x. And then the special limit 3 times 1 minus 1 divided by 5 plus 4 times 1. You get 2 over 9. So part B, I think it's not entirely the same. You see? Now in this session, although it's type 1 limits, because you have this trigonometry in it, and then you can only solve it when you change it to sine x and x. I think in these questions, you can only do that. The only way you can solve it is by doing that. So it takes a lot of effort to change it to the way you would want. I think you will be fine after a few days if you practice enough. But the first time when you do your homework, I will not assign too much because I want to see, maybe I mark it and then I will see, you can see your mistakes and then the next assignment you can correct it. So that's all. Do you have any questions? Now, some students, I don't know, because you didn't turn on your cameras when you were doing classwork. So I don't know. So next week I will find some days I will check your notes during the, at school. I will see if you are done with your notes at least. I warned you last time. I said that last time. I said, oh, I will check it. Don't be offended if I ask. Okay. Any more questions? You must have some, because some of you are going to write differently. I know. If no, you can leave. It's already late. Bye-bye.
Sorry, Miss Chen.
Hello.
Sorry, Miss Chen. I would like to ask: is it cosine 2x is equal to cosine 0?
Where?
Because for like question, extra example 2, page 13. 1 plus cosine 2x equals to 1 plus cosine 0. So it's like cosine 2x equals to cosine 0.
Cosine 2x equal cosine 0?
Yeah.
No, I just put x equals 0 in cosine 2x. That's cosine 2 times 0. That's cosine 0.
Okay. So I would like to.
2 times 0 is still 0. Do you know what I mean?
Okay, I
And
understand now.
Here it's 2 times 0. but
Okay.
still 0.
Okay, thank you, Miss Chen.
Doesn't mean cosine 2x equal cosine x. It's
Okay,
just I put 0 in it.
Okay, I understand now. Thank you, Miss Chen.
Okay, that's all. Bye-bye.